SAT questions of the day, week 6. Number 1 is about getting this quantity ax plus b all by itself. So actually the first thing we're going to do is add 6 to move that over. This way, 9 is a common term, and we can factor it out. Then we can divide both sides by 9. And though we don't know what x is, or a, or b necessarily, the whole thing put together is 3. Number 2, if 50 1-cent coins were stacked on top of each other in a column, the column would be approximately 3 7/8 inches tall. At this rate, which of the following is closer to the number of 1-cent coins it would take to make an 8-inch tall column? I can actually set this up like a proportion. If I put the number of coins on the top and the height on the bottom, I might convert 3 7/8 into a decimal, but you don't really have to. There's 50 coins for this height. How many coins for that height? If I cross multiply 50 times 8 and divide that by 3.875, I get 103.2. The closest answer, B. Of course, you could have just said that this is about 4, and if I want to get to 8, that's about doubling it. 50 times 2, that's about 100. Either way works. Number 3, a customer paid $53 for a jacket after a 6% sales tax was added. What was the price of the jacket before the sales tax was added? Hopefully you're familiar with 6% sales tax, living in Michigan. You could start from the answer choices and multiply them all by 1.06. That's the decimal equivalent of adding 6%. But since this is the price after, you could just start with $53 divided by 1.06. Either way, you're going to get the answer B. Number 4. Teresa ran on a treadmill for 30 minutes, and her time and speed are shown in the graph above. According to the graph, which of the following statements is not true concerning Teresa's run? So if we just look at the graph here, we can see that the speed is increasing whenever the graph's going up. The speed is decreasing whenever the graph is going down. And she's running at a constant rate of speed whenever the graph is flat. So keep all of those things in mind, and also remember that we're finding the one thing that's not true. Did Teresa run at a constant speed for 5 minutes? Right there, yes. Was her speed increasing for a longer period of time than decreasing? 5 minutes here, 5 minutes here, 10 minutes decreasing, 5 minutes decreasing, so that one's the answer. Did it decrease at a constant rate during the last 5 minutes? Yes, that was C. And D, maximum during the last 10 minutes? Yes. B was the only one not true. Number 5, a circle in the xy plane has equation x plus 3 squared plus y minus 1 squared is equal to 25. Which of the following points does not lie in the interior of the circle? So let's remember the equation for a circle with a center HK and a radius R. And that center is determined by these values right here. So the positive 3 for x means our x-coordinate is negative 3, and the negative 1 for y means our y-coordinate is positive 1. Since our r squared is 25, our radius is just 5, the square root of that. So if we plot this on a coordinate grid, 7 or negative 7, 3 will be somewhere around here. Negative 3, 1 is in the center. 0, 0 definitely fits. And 3, positive 2 is actually going to be outside the circle. D. I guess the fast version would be negative 3, 1 is the center. If I add 5 to any of those, well, 3 is bigger than 2, so it's outside of the range. Number 6, y is equal to 1999 plus 1.50x. Like most linear equations, we're looking at a flat fee plus a charge per mile equaling a total cost. So when we find the y-intercept, that's when x is 0, and we plug that into the equation, and in here, our y value is 19.99. That just tells you your flat fee. Number 7, if you spent 15% of an 8-hour workday in meetings, you just take 8 times 0.15. It's almost that simple, of course. Then they want you to translate 1.2 hours into minutes. So you take 1.2 times 60. And the answer is D, 72. Number 8. h of t is equal to negative 16t squared plus 110t plus 72. Whenever you see this negative 16t squared, that's always gravity. So if t is the number of seconds after an object was launched straight up into the air, if we plug in 0 for t in every case, that means no time has went by. So it's probably our starting height, which is just a, the initial height in feet of the object. Number 9 involves lots of small, easy operations that could go wrong if you screw them up in the slightest. I like to start here with b over 2 is equal to 10. If you double both sides, you get b is equal to 20, and that gives you an easy substitution. You can just plug in a 20 somewhere else. So if a minus 20 is equal to 12, well, add 20 to both sides, and suddenly you have a is equal to 32. Some of these have already showed up as answers or as partial answers, but they want to know what the value of a plus b is. 32 plus 20, 52. So we have a scatter plot of income and percent of total expenses spent on programs for 10 charities in 2011. There's a scatter plot with a line of best fit going through the middle. For the charity with the greatest percent of total expenses spent on programs, which seems to be this dot here, by the way, which of the following is closest to the difference of the actual percent and the percent predicted by the line of best fit? So we just draw a line straight down from that dot and the line of best fit. And if we follow over to our y-axis, that's about 7. So the answer is B, 7%.